Okay, so this is page 193, number 11b, okay? Now when I say this is like a reciprocal quadratic equation kind of thing, right? And so what I'm responsible for doing is trying to like solve for x, but the problem is you're probably gonna have two answers this time because you've got a quadratic in the denominator, okay? Now, when I see problems like this, my first move is always to try and factor what I see there so that I can create any kind of common denominators that I need to create, right? And I can't do that unless I see what the pieces are that I'm looking for. And so I'm just going to try and find two numbers that multiply to -24 and add to 6. And so I started running through these numbers, kind of going 1, 24, 2 and 12, 3 and 8, 4 and 6. You could keep going, 12 and oh, you already had 12 and 2. So I don't know. You kind of run out of you run out of steam. 5 skips over kind of thing, and you're like, what is happening here? It's not working, right? So this little thing here actually is not factorable. So now what? So what we did not do in class and did not prepare us for this kind of situation is when we have equalities, okay? If you think back to your grade 9, you had something like this. I don't know, x over 4 is equal to 3x by, who cares, 6. Okay, well, we could, you wouldn't have an x up there, 3 over 6. What we would have done in grade 9 was some like proportional reasoning kind of stuff, is cross multiply and solve for x kind of thing. So with the equalities, we can actually get away with doing this. And I may redo question A as part of this video as an extension, as another way to try and do these problems. So what we can do is actually take the denominator, and we can try to treat this as 1 over 1. We can multiply both sides by the denominator, right? And so you're going to get 3 is going to equal x squared plus 6x minus 24. We have to get a little clever with this, right? At which point now you can take 3 away from both sides, and you're going to have 0 is going to equal x squared plus 6x minus 27. Okay, now we can try and factor that. So two numbers that multiply to -27 and add to +6. That sounds a bit better, right? So it seems like, 127, 2, 3 goes into 27 9 times. Can I make one of those two pieces negative so that I add to +6? The negative can go on the 3. And so I can get 0 is going to equal x minus 3 times x plus 9. And so x can equal 3 and x can equal -9. Okay, so those are the solutions for this one. You have to get a little creative with that. Now, I did a video on question A. What I want to maybe do now is does it work and give us the same answer for question A, right? So for question A, we could also probably use this approach for the equality, right? Specifically, it does not work if you have an inequality. Okay, so do not do this method if you have an inequality, okay? So which is maybe why I just pushed you towards this method in the first place, because we kind of try doing one thing. Most people like doing one thing, right? One style problem, but this required a little bit of creativity. So 7 over x minus 4 is equal to 2. Multiply both sides by the denominator, and so you get 7 is going to equal 2x minus 8. It's probably pretty efficient, right? It might not be a bad way to do these problems. You'd bring the 8 over, you'd have 7 plus 8 is going to equal 2x, you'd have 15 is going to equal 2x, and look at that, we get the same answer. So x is by 15 by 2, and you know what? No common denominators needed. So that's kind of nice. I think if you had the equality, you could do some cross multiplying and solve. That's pretty nice. I would do that maybe. I was in a bit of a snag trying to factor this earlier, and I needed to be resourceful in some things I had done in the past. Okay, so again, caution, can't do this with inequalities. Okay.